Assalamu alaikum, dear friends. In this lecture, we will discuss the solutions for the problem 1.2 of the Marion books. In the previous lecture, we have discussed the equation number 1.10, solution of equation number 1.10, which was cos square alpha plus cos square beta plus cos square gamma is equal to 1. In this, we will derive the proof for equation number 1.11. This equation follows from the law of the cosine and the generalized Pythagorean theorem. First, consider a triangle with two sides being V and V prime, and the last side being the one joining those vectors together. Let theta be the angle between them and r be the length of the third side. Okay, first go to diagrams and then we will try to understand it and find the relations. If I center it so that we can explain it, we are looking at diagrams in which this is our three mutual perpendicular x1 axis, x2 axis and x3 axis. We have this vector of v in x3 and x2 plane. When we translate this by an angle theta and its new position is v prime, so the length of a vector which is changed from v to v prime is equal to r. This is the position vector, the length of a magnitude which is going to be changed from v to v prime. From the image and law of cosine, we can write that if we are given the two vector, this is v vector, this is v prime vector, and this is the angle. So we can find this r by law of cosine. R square will be equal to this is r and this is r prime and this is angle. So r square will be equal to r square plus r prime square minus 2 r prime cos of angle between this vector. If we are given with the length of a two vector, this is vector r, this is vector r prime, and this is capital R the line which is connecting between the two vector, and this is the angle. So if we are given the three sides, two sides of the vector and the angle between them, then we can find the third side from the law of cosine. R square is equal to r square plus r prime square minus 2 r cos theta prime, where r is the length of a v and r prime is the length of a v prime. Okay, now consider the side of the triangle with the length r. If we think about it, the magnitude of its projection, if I center it, the magnitude of its projection on to the coordinate axis should be x minus x prime. Okay, the magnitude for the x axis will be x minus x prime, and the for third is y minus y prime and z minus z prime because we know that R contain x, and similarly y x into I unit vector plus y into j unit vector plus z into k unit vector. Similarly, R prime is equal to x prime into I unit vector plus y prime into j unit vector plus z prime into k unit vector. So the magnitude of this r minus r prime will be equal to x minus x prime magnitude plus y minus y prime magnitude, and similarly plus z minus z prime magnitude. So by the Pythagorean theorem, if we want to find the magnitude of r minus r prime, so it will be equal to the sum of the square of this individual magnitude by the Pythagorean. So x minus x prime का square plus y minus y prime plus z minus z prime square will be equal to r minus r prime का square, which is equal to r. So its square will be r square, where I can leave off the absolute value sign because we are squaring the values. I have taken the only square of the magnitude. If we further solve it, this is the further illustration of our diagram. We you know that this is our original vector is represented by y, and its the coordinate of this vector is y, and the coordinate of this vector is y prime. So the change in the length is y minus y prime. Similarly, you can do the for all other axes. Now we can simply substitute the left side of the equation 2 onto the left side of equation 1 due to the transitive property, and we know that x minus x prime plus y minus y z minus z prime square is equal to, we know the value of this r. This r square is equal to this r square plus r prime square minus 2r r prime cos theta. So we will substitute the value of this r in the place of this. This will lead to this r square plus r prime square minus 2r r prime cos of theta. If we expand the square of this number, similarly this number and this number, it will give the x square minus 2x prime plus x prime square plus y prime square. You know that a minus b square is equal to a square plus b square minus 2ab. Similarly for this relation and for this, so this will lead to the relation like this. Okay, so some term will be cancel out on the left and right side, and you know that r square is equal to x square plus y square plus z square. Similarly r prime ka square is equal to x prime ka square plus y prime ka square plus z prime ka square. So we will write r square is equal to x square plus y square plus, and r prime ka square x prime ka square plus y prime ka square plus z square minus 2r prime cos theta as it. So we will have some term x square plus x prime ka square minus 2x x prime and plus y square plus y prime ka square plus 2y prime. So some term will be get cancelled on the left hand, like x square and this x square. Similarly this y square and the y square, some term will be get cancelled, and we will left with these term minus 2x x prime minus 2y y prime minus 2z z prime is equal to this term. So if we divide this term on the other side, it will give x over r x prime over r prime. Similarly y over r y prime over r plus z over r z prime over r is equal to cos of theta. And we know that x over r is equal to cos of alpha, x prime over r prime is equal to cos of alpha prime, y over r is equal to cos of beta, y over r, y prime over r prime is equal to cos of beta prime. Similarly cos of gamma prime, and this is cos of theta. Thus we have proved our result. Okay, you can comments if you have any problem in these questions.